Welcome to this webcast on the curriculum in design technology. This webcast is brought to you by PrimaryDT and is written and delivered by Laurence Keel. In this webcast, we are going to look at the 5 principles of design technology that act as the driving force behind the development and implementation of a quality curriculum in design technology. The 5 principles are listed on the screen now. As part of looking at these principles, we will cover the importance of children creating a quality product in each of the DT projects they undertake and provide advice on choosing these products. We will also expand further on what is meant by the iterative nature of design technology. Perhaps the most important part of implementing a quality DT curriculum is the concept that children will be building their knowledge as they progress through the curriculum and using this knowledge to make design decisions to ensure that their product is authentic and innovative. Finally, when designing and making their product, we will look at how to ensure children are working in contexts that are real life and relevant to them. If you are currently reviewing or thinking about reviewing your curriculum, these principles, or ones similar to them, are a good starting point and are also worth including in any curriculum documentation for the subject. The first principle is that when children embark on a unit of work, the end point should be that they have created a product. This is probably the most important principle when thinking about creating a unit of work in design technology. Design technology is about creating a product that fulfills a need or that people can use. Designing and making a product for a clear purpose makes it meaningful and helps with the evaluation process, in that the product that has been created can be tested to see whether it functions as it should, fulfills its purpose, or sufficiently meets the need it was designed for. Choosing a product for the children to design and make provides an opportunity to personalise the curriculum, making it relevant and reflecting the location and the context of the school in terms of the culture and the community. It is also an opportunity for the curriculum to reflect the world immediately around the school and engage the school community, stakeholders and local businesses and organisations. In recent years, projects such as designing and making a moon buggy or a model of a Tudor house or a Mayan headdress have fallen out of favour and disappeared from commercial schemes of work. This is mainly due to them not really having a purpose or not really fulfilling a need or not being particularly meaningful to the children. When designing and making a product, children do not necessarily have to create a finished product. As part of the Design and Make challenge, they could be asked to create a model, a mock-up or a prototype of their intended product. Creating models or prototypes is an important part of the creative process for designers. Just as an aside, I would always recommend teachers making a product before teaching a unit of work. This allows them to become familiar with the knowledge, skills and techniques that the children will need. It helps to identify places in the learning sequence that are tricky, where children might need additional support, or there could be potential pitfalls. Also, if you do make the product, teachers will be more confident in teaching the unit and will also have an exemplar to show the children to see how it was made or how it works. So looking at the examples on the screen, in the first image, children are able to create a model to show their ideas for redesign in the local playground. In the second example, children are tasked with creating a prototype for an animal home in the school garden. Creating models, prototypes and mock-ups allows children to work with materials that are easier and more accessible for them to use. This squirrel home was made using waste cardboard. Just imagine primary age children trying to create a similar product using wood. The final example is from a project where children design and make a marble run toy. This again was created using waste cardboard with the focus on children making the product, seeing what worked and then using the finished mock-up to shape their design for the marble run toy. This presents a different creative process that relies on making first before actually designing. All 3 examples on the screen show progression of working with cardboard to create structures by applying a range of cardboard engineering skills. In a future webinar, we will cover in depth how to develop children's cardboard engineering skills. When thinking about products for the children to design and make, one of the key questions to ask is whether the product has an intended user or client. Children need to know who or what they are designing and making the product for. Knowing this will help them with their designs and will also help them when evaluating the product, particularly if they can ask the views of the person they designed and made it for, or can test out their ideas on them. Also, having an intended user makes the project more real life and relevant to the children. There can be a range of intended users that the children can design for. They can design for themselves or somebody at school. They can design for someone they know, a friend or a family member. They can also design for an organisation like the school, the local council, a museum, art gallery or a local shop. Or they can design for an event, and this could be the school fair, a parents' association gathering, or a national event or religious celebration. As mentioned earlier, taking the time to really consider the product that you are asking the children to design and make is a really worthwhile activity as part of developing a quality curriculum in design technology. This allows you to personalise the curriculum to reflect the location and context of your school, making it local and relevant, reflecting the culture and community of the school, and presenting an opportunity to engage parents, the community, and other stakeholders in the DT curriculum. To help you when choosing products for the children to design and make, you can download this simple pro forma for our website that can be used to assess whether the product that you're asking the children to design and make fulfills the criteria for an effective product by answering those simple questions. The iterative process in design technology is about the cycle of continuous improvement. It is about repeating the series of steps that are needed to create a product, and with each repetition, refining of the previous version based on evaluation, feedback and testing of the product. This ultimately leads to continuous improvement and a better final product. Hopefully, most people understand the simple disciplinary process of designing, making and evaluation to create a product. But if we include the iterative nature of the subject, the process shouldn't be viewed as linear, but more of a cyclical nature where, for example, we might evaluate designs and improve them before proceeding to making the product, the proverbial back to the drawing board. Or as part of the creative process, we might make a model of a product, evaluate what we like about the product model, and then use this evaluation to inform the designs that we create. In practice, with limited curriculum time for the subject, what we want to install in the children is the mindset of thinking about how they can improve their product as an ongoing process and not leave evaluation activities to the final lesson at the end of a unit of work. As with any curriculum subject, as children progress through design technology, they should be building and connecting their knowledge of the subject. One of the main aims of the national curriculum is to ensure that all pupils build and apply a repertoire of knowledge, understanding and skills in order to design and make high quality prototypes and products for a wide range of users. Knowledge building is about children getting better at the subject by gaining new knowledge, revisiting previous knowledge and linking this knowledge together to create better understanding. We have covered the 4 knowledge domains in a previous webcast, but it is worth revisiting them again. Subject knowledge is the knowledge associated with a particular topic or product. Technical knowledge is the knowledge of how things work, how things are made, and how to make things work. It is the knowledge that is needed to design and make a product so that it functions as it should. Disciplinary knowledge is about knowing how the subject works. It is about understanding the creative processes of designing, making and evaluating a product. And practical knowledge is knowing the skills and techniques of design technology and knowing how to get better at them. So what do we mean by children getting better? As children progress through the curriculum, they should know more and remember more knowledge about the subject. And this is the idea of sticky knowledge. They should know more about how the subject works and be more confident and have a wider repertoire of the skills and techniques of designing, making and evaluating. As they acquire more knowledge, they should be linking this together to create better understanding and then apply this knowledge and understanding to new situations to create products and to solve problems. And as they make progress through the curriculum, they should be getting better at skills. And when children get better at skills, they have a wider skill set and begin to choose the correct skills for the task. They apply these skills with increasing accuracy. They apply the skills with increased confidence and independence. They apply the skills at a faster rate, and they work safely within set guidelines. To ensure the curriculum promotes knowledge building, we need to develop a curriculum that sets out explicitly what the children are expected to know and remember at each stage of their learning journey. And this can be done at various stages. This might be by each lesson, in each unit of work, over a year group, or over a key stage. And this is the knowledge from the 4 domains: subject, disciplinary, practical, and technical knowledge. Teaching and learning in the subject is then based on securing this key knowledge and making sure that the children know and remember it. It is important that this knowledge is carefully sequenced with plenty of opportunities throughout the children's learning journey for them to revisit and recall this knowledge, link it together and add new knowledge to create better understanding. Mapping out the knowledge that the children are expected to know and remember is the purpose of a progression document. Not only does it sequence children's learning, it can also be used by teachers to identify what the children should know already from learning in previous years and the knowledge that they are expected to teach the children that will be built upon in later years. A really good progression document demonstrates the children's learning in design technology from early years right through to the end of Key Stage 2 and can therefore be used as the basis for assessment in design technology. We will be focusing on progression documents and assessments in webcasts 4 and 5. The 4th principle of effective design technology is about ensuring that the children are involved in making decisions about the product that is going to be designed so that they create a product that is authentic to them. It is highly unlikely that children will design something truly unique or innovative, but instead their designs are likely to be based on a similar product which they adapt with their own ideas and creativity. As mentioned previously, in primary design technology, children will be creating a product that fulfills a need and that people can use. This highlights the care that needs to be taken when choosing a product for the children to design and ensuring that they know and understand who they are designing for, why they might need it or how they might use it. In other words, being very specific about the client they are designing their product for. Once the children know this, they can start making decisions about how they can design a product that will appeal to their client. When designing, children need to be provided with the knowledge to combine with their imagination in order to be creative. So as well as knowing about their intended client, they need to know about existing and similar products, the subject knowledge, and how these products are made and how they work, the technical knowledge. These are vital if they are going to make decisions about adapting a design. Also, children need to have knowledge of the disciplinary processes of designing and how they are used when making and communicating their design decisions. They will need to know, for example, about sketching out ideas, different types of drawing, research, computer-aided design, brainstorming techniques, using mood boards, and the use of models, mock-ups and prototypes in the design process, all of which we will cover in later webcasts. To illustrate the idea of children making design decisions, some examples are given on the screen from our scheme of work. Children design and make a smoothie for a friend. Having learnt about summer fruits and a recipe about how to make a smoothie drink, children are challenged to adapt this recipe for their best friend. They ask their best friend about their favourite fruits and use this knowledge to design and make a smoothie for them. The evaluation is straightforward as the friend drinks the smoothie and then gives feedback to them. This is also an opportunity to learn about the healthy eating messages and 5 a day at Key Stage 1. When working with textiles, children learn about tote bags and how to make them. Having made a tote bag, they then make design decisions about how it is decorated and finished linked to a specific client. This could be a museum or art gallery, or in our scheme of work, the design is to encourage people to be more eco-friendly. So in effect, children are learning to be graphic designers as well as making design decisions about the techniques that are used to decorate the bag. When creating a mechanical toy, children learn how to create a wooden box and add a cam mechanism before deciding on the design for the actual toy. In this case, a model of the solar system to create an orrery. And in the final example, children learn how to create shell structures using a range of techniques before combining these structures together and decorating them to create a desk tidy. As mentioned in earlier webcasts, technology is everything created by humankind. Understanding technology and how it is made and used helps children to understand the world around them. So when working on DT projects, it is important that children are creating products that are real life and relevant to them. The national curriculum states that the children should work in a range of relevant contexts. It goes further in providing examples of these relevant contexts at each key stage. These examples are non-statutory and allow schools to develop a curriculum for design technology that is local to them and reflects the context of the school and the community where it is located. Such freedoms also allow schools to develop a curriculum that is culturally relevant to the children. Choosing a product that is real life and relevant, as well as engaging the children, is also an opportunity to engage parents, the local community and businesses with the school curriculum, and also provides opportunities for enrichment activities by inviting in or visiting people who make a living from design technology related activities. Now, sometimes we just need to tweak existing units of work or projects to make them more real life and relevant to the children, as we will see in this following example. Designing and making a soft toy is a popular choice for Key Stage 2 when learning about textiles. In this example, children are challenged to design and make a soft toy for a charity to use as part of a fundraising campaign for the charity. In this unit of work, children design and make a soft toy, applying their knowledge of textiles, sewing techniques, creating textile pieces using pattern templates, and sewing them together using a seam allowance. They consider a range of decorative finishes before deciding on which ones to use on their chosen product. In designing their soft toy, children need to take into account their client, the charity they are designing for, and to investigate existing soft toys and to discuss what makes a good soft toy. They will also undertake research into animal charities that gift a soft toy to people who donate to them. On the following two slides are some more ideas about how popular units of work could be slightly tweaked so that they become real life and are set within a relevant context for the children. For those of you who are using this series of webcasts to review provision for design technology in your school, Section 3 of the audit focuses on the 5 principles of effective design technology and can be downloaded from the webcast section on our website. Use these audit questions and the content from this webcast to identify how well your curriculum in DT reflects these 5 principles. That concludes the webcasts on the 5 principles of effective design technology. We hope you've found them useful. In the next curriculum focused webcast, we will look closer at the principle of knowledge building in the curriculum and how this is linked to the development of a progression document, and then how that progression document can be used for the basis of assessment in design technology. All units of work, product examples, teaching ideas, photos and learning activities featured in this webcast have been taken from the PrimaryDT scheme of work. The PrimaryDT website provides information about the content of over 50 units of work that have been written as part of the Primary Design Technology scheme of work. Each unit is available for immediate digital download from the website. Each unit is priced at £10 and includes medium-term planning, lesson presentation slides, a knowledge organiser and all the digital resources needed to teach the unit. Discount prices are available for schools wishing to buy multiple units in order to create a scheme of work or to supplement their existing scheme. The PrimaryDT website also contains many resources and guidance that can be downloaded free of charge. Laurence Keel has over 35 years' experience of working in primary education as a teacher, head teacher and local authority school improvement advisor. He has authored several books covering design technology, art and design, science and STEM subjects in primary education. Laurence has worked with PrimaryDT in creating the Primary Design Technology Scheme of Work. Laurence works across the country providing bespoke CPD for schools, academy trusts and local authorities. Please contact support@primarydt.com if you are interested in booking some bespoke CPD for your school or organisation.